Hello and welcome to another GCSE maths lesson. Today we're going to look at algebra and in particular rearranging formulae. Now I know many of you find it difficult, especially in some of the harder questions when it comes to rearranging formulae. So we're going to go through a few questions today and hopefully iron out any issues and any problems. So if we start with the first question. And the question is, make A the subject of the formulae 2 brackets 3a minus c equals 5c plus 1. So we're going to attempt to answer this question and pick up any key concepts and takeaway points along the way. Right, so first things to note is we are looking to make A the subject of this formula. So on the left-hand side I've got 2 brackets 3a minus c equals 2, on the right-hand side 5c plus 1. So step 1 is going to be expanding this brackets out and writing the equation out in full. So if we do that, we have 2 times 3a, which is 6a, 2 times minus c, which is minus 2c, and that equals to 5c plus 1. Right, now always note that the purpose of this question is to make A the subject of the formula. So, what we have here on the left-hand side is we've got your 6a. So we've got A on the left-hand side. On the right-hand side there's no A's. But on the left-hand side we also have this minus 2c. And what we want to do is essentially to remove that from the left-hand side. Now, because it's minus 2c, we need to do the opposite. So the opposite of take away is to add. So if we add 2c to the left-hand side, minus 2c plus 2c is going to equal to 0. We're going to have to do the same thing on the right-hand side. So what we get then is 6a minus 2c plus 2c equals 0, equals to, on the right-hand side, 5c plus 1 plus the 2c. Now it's quite straightforward. If we simplify the right-hand side, that's going to be 5c plus 2c is 7c plus 1. So we have 6a equals to 7c plus 1. And we want a on its own. So at the moment we've got 6 times a. Now the opposite of multiply is to divide. So if we divide the left-hand side by 6 to get a on its own, we would do the same thing to the right-hand side. So what we get is a, because 6a divided by 6 is equal to a, the 6 and the 6 will cancel out. So we have a equals 7c plus 1 divided by 6. And that is your answer to this question. The next question then is slightly more challenging, but let's have a go at it. And you'll see that the same concepts that we applied in the first question also apply here. So this question, we have an equation which is d equals to the root of 3h over 2, and what we're asked to do is to make h the subject of the formula, so h equals to something. Right, so let's take this in turn. So we have d equals to the root of 3h over 2. Right, I want to get h on its own. So what can I do here? What's the first thing we would do? Well, the first thing we would do is to recognize that we have a root. So how am I going to get rid of this root? Well, again, just do the opposite. Just like we did in question 1. If you've got a root here, the opposite of a square root is obviously just a square. So if we square the right-hand side, the root and the square will cancel each other out. And we've got to do the same thing to the left-hand side. So we would have d squared equals to 3h over 2. So the square root and the square cancel out. And now we've got 3h over 2, so the opposite of divide is to multiply. So if I multiply the right-hand side by 2, so if we did this times 2, then we've got to do the same thing to the left-hand side. So the right-hand side, the 2 and the 2 are going to cancel out to leave us with just 3h. The left-hand side, we'll have d squared times 2, which is obviously just 2d squared. So we've got 2d squared equals to 3h. And now it's easy to get h on its own. Well, you can see on the right hand side we've got 3 times h. So the opposite of multiplication is just division. So our answer would be h equals 2d squared over 3. Question 3 then, slightly more challenging. So let's have a go at this. We'll do this question and then one more, and hopefully you should be okay with rearranging the formula. It doesn't really get much harder than this, so after this I would encourage plenty of practice, and then you should be okay. So this question then, so question 3, we have p equals to n squared plus a over n plus a. And what we're asked to do is to rearrange the formula to make a the subject. Right, okay, so first step then, we've got p on the left hand side, on the right hand side we've got n squared plus a over n plus a. So we want to get rid of this fractional form. So what we can do here is to multiply both sides by n plus a. So if we did the right hand side times the n plus a, we've got to do the same thing to the left hand side. So you would have p times by n plus a equals to n squared plus a. And the reason it's just n squared plus a on the right hand side is because the n plus a and the n plus a here, they both cancel out. So what do we do now? Well, we would expand out the bracket. So on the left hand side we're going to have pn plus pa equals to n squared plus a. Right, we want to get a on its own because we want to rearrange this formula to make a the subject. So let's collect the like terms. We can see at the moment that on the left hand side we have an a, on the right hand side we also have an a. We want the a's to be on one side together. So if I bring the PA from the left hand side to the right hand side, what I need to do here is to take away PA from both sides, because the opposite of addition is subtraction. So we would have PN plus PA minus PA, so they cancel out, equals to n squared plus A minus PA. Right, my next step then is to get rid of this n squared and bring it to the left hand side, because we want all the a's together on one side on its own. So we would do, so to get rid of this n squared, obviously at the moment it's n squared plus, so we would take away the n squared because the opposite of addition is subtraction. So we would have on the left hand side then Pn minus n squared, and on the right hand side we would just have the A minus PA. Right, now what do we do? Well, this step is key, and this is something you need to realize. So on the right hand side we have the A minus PA, and I want A on its own. So what can I do? Well, I've got two factors here. I've got an A and a PA. What I can do here is to factorize. So if I take the A outside, in my bracket I would have 1 minus P, because if I expand this bracket it would give me A minus PA. On the left hand side I've still got my Pn minus n squared. And the reason we do this factorizing process is now we can get A on its own, because on the right hand side now we have A times a 1 minus P. And I can get rid of this 1 minus P by doing the opposite of multiplication. So I can divide the right hand side by 1 minus P, and if I do that to the right hand side I've got to do it to the left hand side. So what happens? Well, on the right hand side the 1 minus P and the 1 minus P cancel out, and I've got my A on its own. which is essentially my answer. So my answer is A equals to Pn minus n squared over 1 minus P. Right, okay, so next question then is going to be our final question. And this one says, make x the subject of the formula. And the formula is x over x plus c equals p over q. So we want to make x the subject of this formula. So at the moment on the left hand side I have got a c in there. Obviously I don't want that. Again, what we would do here is to try and get rid of this fraction. So how am I going to do that? Well, if I multiply the left hand side by x plus c, then I've got to do the same thing to the right hand side. So I will have x times by x plus c over the x plus c, and the same thing on the right hand side, p times x plus c over q. But we can see now on the left hand side the x plus c and the x plus c will cancel out, and I have my x on its own on the left, which is what I want, but I've still got an x on the right hand side. So let's write this out first. We've got x equals to p multiplied by x plus c divided by q. Right, now if I multiply both sides by q, because again I've got a fraction here and I don't want a fraction here, we would have xq equals p brackets x plus c. Now at this stage you may be noticing that what we're going to do here essentially is to expand this bracket, rearrange it, and then there will be some factorizing involved. You should be able to see that here. So let's see. We have, if we expand this bracket out, we've got xq on the left hand side equals to xp, because p times x, plus cp. Now again, just like before, we want to keep all the x's together and everything else on the other side. So if I bring the xp from the right hand side to the left, because it's add or plus xp on the right, I need to do the opposite. So I will do minus xp from both sides. So I have xq minus xp equals cp. Right, so now I can see on the left hand side I'm going to have to do my factorizing, which means that I need to, what I want to do is to take the x out on its own. So I will have x out on its own here, open bracket, or x times what gives me xq, well, it's just q, and then x times what will give me minus xp, well, it will just be minus p, and on the right hand side is just the same thing, which is cp. And now I'm practically done, because now on the left hand side I've got x times q minus p, or the opposite of multiplication is division. So I will divide both sides by q minus p to give me the x on its own on the left, because the q minus p and the q minus p cancel out. So I've got x equals to cp over q minus p, and that is my answer.